pseudo multivariable problems, pseudo calculus problems. Okay, we are pursuing discussion in pseudo calculus problems. Okay, pseudo calculus problems. In the pseudo calculus problem, okay, it would be matter of laughter that we are trying to calculate area of a circle. Area of a circle. What is surface area? What is area of a circle? Okay, why saying it is a matter of laughter would be that everyone knows that area of a circle is pi r square, where r is radius of a circle. But it looks very simple when someone knows it that this is the area of a circle. Otherwise, calculating the area of a circle is pretty difficult. I would rather say it is impossible. The shape it carries, the round shape, it is impossible to calculate the area of a circle. Anyway, in that fashion, we are in discussion calculating the area of a circle in polar coordinate system in a way that we take everything in polar coordinate system. What is polar coordinate system? Polar coordinate system has radius and theta. What is the association of polar coordinate system? Association of polar coordinate system with the Cartesian coordinate system. What is the relationship of polar coordinate system and Cartesian coordinate system? The relationship is that if I take polar coordinate system and Cartesian coordinate system together, then radius cos theta is x and radius sin theta is y. Means if I draw a polar coordinate system in a Cartesian coordinate system, hybrid model. If I create a hybrid model, this is Cartesian coordinate system where this is x-axis and this is y-axis, this is x-axis. This is origin and then this is y-axis, this is x-axis. If this is the case, then this is Cartesian coordinate system where y-axis means height, where height is at the origin, height is maximum and height is decreasing if I move along x-axis. Height is increasing and height is decreasing again. Height equal to a square root of a square minus x square. Y equal to a square root of a square minus x square. If x is 0, y equal to plus minus a. If x is 0, then y equal to plus minus a. Okay, when x is a, y equal to 0. When x is minus a, y equal to 0. Means when x equal to 0, y is plus a, y is minus a. When x is a, y is 0. When x is minus a, y is 0. Okay, and this is the Cartesian coordinate system. What about polar coordinate system? Polar coordinate system has a radius r, and radius is going along in theta angle variation. Means radius is not varying. If I take a particular radius, consider this is a particular radius a. This radius would shift in this fashion with angle theta. Angle theta is an angle that is made when radius is moving like this all along the parameter. This is this is polar coordinate system. But polar coordinate system, as we say, polar coordinate system, as we draw, then this is theta and this is radius. This is theta and this is radius. Okay, can anyone think about polar coordinate system in polar coordinate? This is theta and this is radius. In that way, how radius and theta are associated to each other. If this angle is 0, theta is 0, I can move this angle 0 to 360 degree or 0 to minus 360 degree and so along. Okay, in that fashion, if I see this as a, this is a point to be noted. Okay, this is this is x-axis and this is y-axis. I'm sorry. This is theta axis and this is r axis. This is a polar coordinate system. In polar coordinate system, when theta is growing, then radius, if you see radius, then radius is flat. It is unchanged. It is always r. With variation in theta, radius does not vary. With variation in theta, radius is always constant. Radius is unchanged when theta is changing. Okay, what about when radius is changing? If radius is changing like this, then theta is unchanged. Theta is not changing. Theta is neither theta and radius are independent to each other. It looks like in that fashion. Okay, that is polar coordinate system as far as circle is concerned. But as far as circle is concerned, then if I talk in xy coordinate, then as x vary, then y vary, and it makes a circle in that fashion. That is like this. This is Cartesian coordinate system when I am talking about a circle where y equal to square root of a square minus x square. This is xy coordinate. Okay, if I talk about a circle in polar coordinate, if I talk about a circle, if I talk about a circle in polar coordinate, then it will look like this. Okay, anyway, this is the fundamental. Now through polar coordinate can be extended. Polar coordinate is r and theta. Polar coordinate can be extended to cylindrical coordinate system. Polar coordinate can be extended to a spherical coordinate system. Means r and theta, if I add z, then it becomes cylindrical coordinate system. Similarly, if I have r and theta and if I add vertical angle also, it becomes a spherical coordinate system. What is the area of a circle? That is under question mark. Now, what we have seen till now, the area of circle, if I take on a circle, if I take a position vector, if on a circle, if I take a position vector, then the dp by d theta cross dp by dr d theta is the area of a circle. Please watch our previous video. So in previous video, we have demonstrated that area of a circle is nothing but dp by d theta cross dp by dr d theta. Okay, now anyone would come forward and say, can you disclose what is your magic dp by d theta cross dp by dr? We started the discussion that consider the area of a circle is A. Area of a circle is A. If area of a circle is A, I can write A. A equal to A by theta r into theta r. Just write it. What is there in writing? A by theta r into theta r. Okay, I believe it is all right. A by theta r into theta r. Okay, in that fashion, consider A is the area of a circle. Consider A is an area of a circle. So in Cartesian coordinate system, there are two coordinate systems right now we are talking. There are two Cartesian coordinate systems right now we are talking. One is Cartesian and one is polar coordinate system. Cartesian coordinate system, there is a circle and this is x and y coordinate system. In polar coordinate system, there is a rectangle and this is theta and r coordinate system. In xy plane, x equal to r cos theta. This is how x and r theta are related to each other. In xy plane, we have x and y. And in theta r plane, we have a rectangle. Rectangle is mapped into circle in, in xy plane from the r theta plane. Okay, what is the area of this rectangle? R into theta, where this is theta and this is r. What is the area of the circle in Cartesian coordinate system? X and y plane. A. Just A. Okay, then A equal to A by r theta into r theta. A by r theta into r theta, where A is the area in xy plane by r theta is the area in r theta plane into r theta. Like any can write mathematics, 5 equal to 5 by x into x. Now what is A by r theta? They will stick together like a magnet and iron. A by r theta. A is an area in xy plane, and this is a function over this is a something that is x and y. And whereas r theta is area in theta r plane, they are related to each other. X equal to r cos theta, y equal to r sin theta. Means if I say a by r theta, where numerator is dependent upon denominator, numerator is in x and y, and denominator is in r and theta, where x and y is dependent upon r and theta. X equal to g theta r, x is a function over theta r, y equal to h theta r, y is a function over theta r. If I have a division where numerator is divided by denominator and numerator is dependent upon denominator, then division turns into differentiation. Okay, now it becomes a dA by dr theta. In that sense, I'll change the numerator as dr theta, dA by dr theta into dr theta. Now, what is dA by dr theta? Per unit area change in r theta plane brings how many unit area change in A? So, in r theta plane, I took any point theta comma r, and then I proceeded theta plus delta theta comma r, 1 point. I mean, if I have any point in theta r plane as theta comma r, 1 point. I proceeded in theta direction, I took another point as theta plus delta theta comma r. Then I proceeded in this direction. I took another point as theta comma r plus delta r. Now we have 3 points. Theta comma r, theta plus delta theta comma r, theta comma r plus delta r. Means we have a small rectangle at point theta comma r as delta theta delta r. Means area of this. Someone can take other way also. If theta comma r is a point, then I can proceed theta plus delta, I'm sorry, I can proceed delta theta by 2 comma r, and here I can proceed theta comma r delta r by 2. I mean, theta comma r point will come at the center of a rectangle, that is delta theta delta r. Makes sense? Means around that theta comma r point, I took a small rectangle which is delta theta delta r, or at delta theta r, I took a small rectangle where theta comma r, there is a point theta comma r. There, I made a small rectangle, okay, where theta comma r point is bottom left and rectangle is delta theta delta r width and height. Or delta comma theta will be at the center and rectangle will be delta theta delta r. Anything. Now similarly, I have 3 points here also. One point is x comma y as per theta comma r mapped point, and here it is g theta comma r comma h theta comma r, and then another point is g theta plus delta theta comma r h theta plus delta theta comma r, where is the g x equal to g theta comma r. X is a function over theta and r. Y equal to h theta comma r. P point is g theta comma r h theta comma r. P1 point is g theta plus delta theta comma r h theta plus delta theta comma r. This point is g theta comma r plus delta r h theta comma r plus delta r. If I say that I have made a rectangular region here delta theta delta r, then there is another region that is created, that is P1 P cross product P2 P. If P is a vector, that is xi plus yj, or g theta comma r comma g theta comma ri plus h theta comma ri, then there is another point here, that is g theta plus delta theta comma r I plus h theta plus delta theta comma r. Okay, similarly there is another point P, and that is g theta comma r plus delta r I plus h theta comma r plus delta r j. Okay, j. In that sense, the area is P1P cross P2P. If these two vector, if I do cross product, it shows the area. Means dA by d theta r. Change in one unit area in theta r plane brings how many unit of area change in A? I have made at point theta comma r a area change is delta theta delta r. So I'll place d theta r as delta theta delta r, and in dA I'll place P1 cross P2. Okay, delta theta delta r, P1 cross P2. Down is delta theta delta r. Delta theta I can keep left side, and delta r I can keep right side. It becomes P1 P by delta theta cross P2 P by delta r. P1 P, if someone see P1 P, that is G theta plus delta theta comma r minus G theta comma r I plus G theta comma r plus delta r. I'm sorry, it is G theta plus delta theta comma r minus G theta comma r I plus H theta plus delta theta comma r minus H theta comma r j by delta theta. It is exactly d of G theta comma r I plus H theta comma r I by d theta. Cross product d of G theta comma r I plus H theta comma r I by dr. It becomes dp. Position vector is indeed it is G theta comma r I plus H theta comma r I. It becomes dp by d theta cross dp by dr. If I say it is what is your area vector? What is area vector in xy plane? It is dp by d theta cross dp by dr into d theta r. D theta r becomes delta r or d theta dr. This is called area vector. Magnitude of this area vector will give the surface area? Certainly not. I'm sorry. I'm sorry. Certainly yes. If position vector is in x and y. So we saw x equal to r cos theta, y equal to r sin theta, dp by d theta, where p is r cos theta and y is r sin theta. In that sense, it become r minus sin theta I plus r cos theta j cross product dp by dr cos theta I plus sin theta j. If someone does this cross product, he will land up into r. He will land up into r k vector. It will become r cos square theta plus r sin square theta k vector, and then dr d theta. It will become r k vector d theta dr. This is also a way to calculate Jacobian. Anyway, now if that is the scenario, then what is the area? Magnitude of this area vector is the area r d theta dr. If someone calculate r is from 0 to a and theta is 0 to 2 pi, it will become pi r square or pi a square only. This is one thing we saw in the polar coordinate system. Other thing we saw, can we use this fundamental dp by d theta cross dp by dr? dp by d theta cross dp by dr in pure polar coordinate system. What is pure polar coordinate system? If I talk about pure polar coordinate system, then if this is a circle, then pure polar coordinate system, if I take any point P here and this is center, the P point is r comma r theta. Okay, if this is the radius, if this is consider this is Cartesian coordinate system, and this is x axis, this is y axis. In that fashion, if I take any point P here from center, if I take this position vector in Cartesian coordinate system, then this point P is x comma y. But if I take in take in polar coordinate system, then this is radius, then this is r, and this is at angle theta. This is at angle theta, then this is theta. The position vector is point is r comma theta, but that is not true. Theta is just an angle. It is not the distance. We need distance, not the theta. R is distance from center. Then distance, if I talk in theta, then if theta is 0 here, and if I talk about distance, then this distance will be the arc which theta is making, that is r theta. So that point is r comma r theta, or position vector is r unit vector plus r theta unit vector. Okay, this is the, so if I say dp by d theta, it becomes r unit vector plus r theta unit vector by d theta. This is in pure polar coordinate system. Plus dp by dr, d of r unit vector plus r theta unit vector by dr d theta, but it will not work. Why it will not work? Because d theta d, if I just talk about the, if I taken Cartesian coordinate system that was in I and j, then we talked about two coordinate system. One is x and y and one is theta and r. They are different to each other. In that sense, this area vector will work. But if I take only polar coordinate system, then in this area vector d theta dr will not work because there are two independent components. If I take only polar coordinate system, then area vector, if I talk about the calculation of area, then there will be only one independent component, not two independent components. Calculation of area, if I take the Cartesian coordinate system, there can only be, if I talk in x and y, then there is only one independent component, that is x. That will be the area will be calculated through dx, not dx dy, because dx and dy means both are independent to each other. This is not true. Okay, x and y are not independent to each other if I see in two dimensions. Y is vertical, is dependent upon horizontal. But if I take three dimension, then vertical is dependent upon horizontal plane, and a horizontal plane includes x-axis and y-axis, and here they are independent to each other. Similarly, if I am trying to calculate area with dp by d theta cross dp by dr, dp by d theta cross dp by dr, then in that way, d theta dr, I am taking only two dimensions. In two dimension, I am taking two independent variables, d theta dr. It will not work. It cannot be. Either d theta will be there or dr will be there. Both cannot be. If I want both, then I have to take three dimensions. The three dimension of polar coordinate system is either a cylindrical coordinate system or a spherical coordinate system. If I take three dimension, then I have to go with the three dimension calculus, that is volume of a cylinder, where height is 1. Means if I calculate the volume of a cylinder when height is 1, indirectly it will give the surface area only. In that sense, whatever area vector we are calculating, then in volume calculation of a cylinder, height, that is z, is dependent upon theta r plane, where theta r plane is independent component and z is dependent component. In theta r plane, theta and r are independent to each other, hypothetically, whatever it is. In that sense, our area vector dp by d theta cross dp by dr, d theta dr is area vector dot product with zk, that is the height vector in polar coordinate system, in cylindrical coordinate system. If someone tries it where theta and r are independent to each other, now dp by, we have talked about it past video, dp by d theta, p is r unit vector plus r theta theta unit vector by dp by d theta. If dr by d theta will be 0 because they are not related to each other, it will become r theta unit vector d theta by d theta 1, r theta unit vector. Cross product, other side dp by dr, r unit vector. That side r d theta by dr will be 0. R unit vector cross product with the r theta unit vector. It will, I'm sorry, it will become r k unit vector. R k unit vector d theta dr is the area vector. Okay, if people want to go more with our pseudo length vector, what is the length vector in polar coordinate system? If I polar coordinate system, any line in polar coordinate system, any position vector or any straight line can be represented as r unit vector plus r theta theta unit vector. That way, any line can be represented. If line can be represented in that fashion, how the curve line can be represented in theta r plane? In that sense, I have to take out one independent variable. It will become representation of the curve line in vector. Please watch our previous video. So like we take out x and we represent in y by x. Here, I have a position vector, line vector in theta r plane, or polar coordinate system is r unit vector plus r theta theta unit vector. If I take out theta, then it will become dr by d theta r unit vector plus r theta unit vector. Okay, this is called length vector, in length vector that represent a curved line in theta r plane polar coordinate system. If I am trying to calculate area, then it will be cross product of two length vector. One vector is r unit vector plus r theta theta unit vector. Another is same r unit vector plus r theta theta unit vector. From one side I will take out theta and one side I will take out r. Okay, it will become r by theta r unit vector plus r theta unit vector cross product, I'm sorry, bracket close into theta because theta I took out. Cross product that side r I will take out. Then it will become r by r unit vector plus r unit vector plus r plus, I'm sorry, plus r theta by r, theta unit vector into r. Division I can change it to differentiation and multiplication I'll change it to integration. So first would become dr by d theta r unit vector plus r theta unit vector bracket close d theta cross product with r unit vector plus r d theta by dr theta unit vector bracket close d dr. Okay, if I settle it down, it becomes dr by d theta r unit vector plus r theta unit vector. Okay, cross product with d plus cross product with r unit vector plus r d theta by dr theta unit vector d theta dr. It is exactly as dp by d theta cross dp by dr d theta dr. Same thing. Okay, now we know that our area vector is dr by d theta r unit vector plus r theta unit vector cross product, that is dp by d theta cross product with this we brought through the length vector concept also, cross product with r unit vector plus r d theta by dr theta unit vector bracket close d theta dr. Now this is area unit vector, but we cannot calculate area with this unit vector because there are two independent components coming here, d theta dr. To settle the independent component, I have to talk about the volume where height is 1. In that way, it will become, so it will become, now we will say we are not calculating the area vector, area. We are calculating volume where height is 1 in cylindrical coordinate system. If I take a cylinder and I calculate the volume where height is 1, indirectly I am calculating the surface area of the bottom circle 1. In that fashion, it will become zk, that is the height vector, zk dot product with the area vector. Now in this area vector, z is dependent upon theta r plane, where theta plane r plane is independent and z is dependent. Now in theta r plane, theta and r are independent to each other. Okay, in that fashion, dr by d theta will be 0 and d theta by dr will be 0. At the end, it will become r unit, I'm sorry, it becomes theta unit vector cross product with the r unit vector, or r theta unit vector cross product with the r unit vector. It will become r k unit vector dot product z k unit vector. Z is 1, k dot product will become nothing, 1. It become r d theta at the end only, r d theta, and then the volume calculation for the height 1 r d theta, where r is 0 to a and theta is 0 to 2 pi, will be pi r square, pi a square. What is the today's fundamental that we are bringing? We will calculate the volume when I have a cylinder of height 1. I have a cylinder. Of height 1. Okay, what is the cylinder I can take? Okay, so consider this is a cylinder. It doesn't look like a cylinder. Consider this is a cylinder. If this is a cylinder, then this is the base circle and this is the top circle of a cylinder. If this is a cylinder, then this is the top circle of the cylinder and this is the base circle of the cylinder. If that is the case, then height is 1. Consider a cylinder which base is a circle for which we are trying to calculate the area and height is a circle. Certainly, cylinder will have a top circle and bottom circle and they are of same area. Consider a cylinder of height 1. If that is the case, can we calculate the surface area of top circle in pure cylindrical coordinate system? not in the hybrid model means r unit vector, theta unit vector, k unit vector. If I calculate the surface area of top of the cylinder, then surface area of the bottom of the cylinder circle will be same. Now, if I take top circle, then I can cut the circle in z theta plane, and I can cut the circle in z r plane. Makes sense? If I have a top circular region of a cylinder, I can cut the circle in z theta plane. Mind it, I'm not saying z x plane or z y plane. Z theta plane and ZR plane, then it will make a line. If I cut as a plane, it will make a line on the top surface. It will make a line on the top surface. One is Z theta plane, one will be ZR plane. If that is the case, then what is the position vector? What is the length vector in the Z theta plane, and what is the length vector in ZR plane? That is the concept now. Anyway, if I take any position vector on the circle, if this is the top circle of this, okay, this is a cylinder. This is a cylinder, and this is the top surface. If this is the top surface, on this surface, take any point P. What is P? That is R unit vector plus R theta unit vector plus Z K unit vector. That is the point there. Now, if I cut in z theta plane, if I cut it in z theta plane, what will be the line equation? That will be the line equation where the r will be constant. In z theta plane, r will be constant. In z r plane, theta will be constant. If that is the case, z r plane and z theta plane, if that is the case, then what will be the if I take cross product, if I this is the top circle. Consider this is the top circle, this is the top circle, and this is the bottom circle, and there is a cylinder of height 1. Okay, on top circle Z is not varying, but I have taken any point on the top circle, point P, and at P I make a cut in Z theta plane, and at point P I make a cut in ZR plane. Then there will be a line, there will be line, then if I say this was my point P, then at point P there will be a line that is in Z theta plane, and there will be a line in ZR plane. This is point P. If I cross product of these two, then at point P, this will be called area vector. Area vector means at point P, because everywhere area vector may change. After all, this is algebra. So area vector at point P is cross product of a line in Z theta plane and cross product of a line in ZR plane. If I do cross product, then it will be area vector. Now, what is the line equation? What is the point P? Point P is R unit vector plus R theta unit vector plus ZK unit vector. Okay. Now, this is the point P in the Z theta plane where R is constant. Cross product with R unit vector plus R theta unit vector plus ZK unit vector in ZR plane where theta is constant. Now, if I'm trying to do cross product of these two to calculate the area, from one side I will take one independent component. In Z theta plane, theta is independent component, R is constant, and Z is variable in a function of theta. Then theta I would take out, and it becomes R by theta R unit vector plus R theta unit vector plus Z by theta K unit vector. Bracket close into theta. Cross product from that side I will take out R. Then it will become, that is another independent component in ZR plane. It will become R unit vector plus R theta by R unit vector, R theta by R theta unit vector plus Z by R K unit vector. Bracket close into R. Now division I will turn into differentiation and multiplication I will turn into integration. Now it becomes dr by d theta, where r is constant in z theta plane. Dr by d theta is 0. Dz by d theta will be there, but z I have taken on the top surface where z is everywhere, it is constant. In that sense, dz by d theta is also 0. It will remain as r theta unit vector. Cross product or r theta unit vector into theta. into theta will become d theta. R theta unit vector into d theta. Multiplication will become integration, where left side is a function over right side. Cross product, now here it is dr by r, so it is r unit vector plus r d theta by dr. Here theta is constant in zr plane, so 0. Dz by dr, z is not changing on the full top surface, that is also 0. Only r unit vector will remain, and here r theta unit vector will remain. It will become r theta unit vector cross r unit vector, r k unit vector, r k unit vector, d theta dr. This is the area vector. If I take the magnitude of this area vector, if I calculate magnitude of this area vector, then certainly it will give the area r k unit vector, d theta dr. In that fashion, it will become r d theta dr. R is from 0 to a and theta is 0 to 2 pi. In that sense, it becomes pi a square. So pi a square is the area of a circle. We will see more fundamentals into it. Means it. I thought I would end it today. We will try variable circle. Circle that is variable in polar coordinate system. Right now I have taken constant circle. Constant circle means theta and r are independent to each other. There can be a circle where theta and r are dependent to each other, like r equal to cos theta. Can someone draw a circle where r equal to cos theta or r equal to sin theta, r equal to cos theta plus sin theta? These are circles. Can someone try writing a circle that is r equal to cos theta, r equal to theta? These are the new fundamental. In that way, theta and r plane if I take, then it will not be a rectangle. If I take theta and r, this is theta axis and r axis, theta r plane, where r equal to cos theta, then r and theta are not independent to each other. In that sense, diagram will not be rectangle. It will be sinusoidal or cos wave. It will not be rectangle. So this complex circle also we will take and try to calculate the area. We'll try one more time with the spherical coordinate system. Okay, anyway, please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 94831610606110 is the telephone number.